This video deals with kinematics or dynamics problems for the level 3 BTec course and for the mechanical principles module. It would be called normally SUVAT or SUVAT problem we're going to deal with, which is dynamics problem. What we're going to do is basically consider a problem or an event which takes place which has got a constant acceleration, and we're going to use our 5 variables to describe the event, the acceleration or the dynamic problem. Here S is the distance covered, U is the initial velocity, the start of the event, V is the final velocity at the end of the event or at the end of the journey, A is the acceleration, the constant acceleration throughout the event, and T is the time taken for the journey time. So let's put in a nice simple problem here. There we go. Here's our track, here's our start point, here's our finish point here, and we're going to consider a little car which is accelerating at a constant rate here. It accelerates and it finishes just here. Okay? And so the car here has got an initial velocity of 0. In the text or in problems that you're going to encounter, that would be describing as starting at rest. Okay, so it starts at rest and the initial velocity is 0. It then accelerates from rest or accelerates from 0 and covers this distance here, okay, this distance here, which is described there with our letter S. Okay, it's got a constant acceleration, okay, which is A, and the time taken for the journey is also taken into consideration. Okay, so we've got our 5 variables there, and V is given at the end of the journey there. Okay, we're going to take the car here. We're going to say that the car has got an acceleration, or capable of an acceleration, of 4 meters per second squared. Okay, meters per second squared, the units or units for acceleration. Notice we're always using SI units. If we use SI units for all of our variables, when we put them into the equation, we're going to get the right answer out the other end. Okay. We know that the initial velocity is 0, and we're going to say that this particular case, the time taken is going to be 5 seconds to cover the distance. Okay? It's important to remember with these problems that once you've got 3 of the 5 variables in the SUVAT, okay, you can find the other 2. And in this case, we're going to use an equation of motion to calculate the distance that's been travelled here. Okay, so we've got these 3, and we're going to use those 3 to calculate the distance that's travelled. You've got in the course notes and also on Blackboard, you can see a list of all the equations, the 5 or 6 equations of motion that we can use, and the one I'm going to use today is going to be S equals ut plus a half at squared. Okay, so S is the distance, okay, the distance of the journey that we're looking for. S is the subject of the equation, so we don't have to change it round. All we have to do is take these values, put them into the equation, and it will give us the value here of the distance in meters. Remember, meters is the SI unit, standard for SI units for distance or length. So let's have a go. S equals the initial velocity here, U, is 0. Remember, when you've got an equation like this and the variables are close together, that means they're multiplied. T is 5. Okay, remember we don't have to put seconds in the equation, we just put the numbers in the equation. Plus a half there, times the acceleration, which is 4, times 5 squared, Okay, and there we are. All the values are in there. The first term here, where you've got initial velocity of 0, obviously 0 times anything is going to be cancelled out. So in our next line down, that's going to be 0 plus, in here, half of 4 is 2, so I can cancel out that one there, that goes 2. Okay, 5 squared is 25, so in this case here we're going to have a bracket with 2 times 25. Okay, and therefore our distance S here, okay, is going to be equal to 2 lots of 25, which is 50, and our SI units for distance is meters. Okay, it's quite simple. It's as simple as that. Okay. So in this particular case, this particular event here, where we're starting at rest, the car's travelling a certain distance at 4 meters per second squared in a 5-second journey, the distance that's covered is going to be 50 meters. So we can now fill in this other variable there in our SUVAT, and we can go on to find the value of V. Okay. Let's try a slightly different question. Let's try, in this case we've got a horizontal journey or a horizontal event. Let's turn it the other way round, and let's consider something like a ball or an object, a small mass, that's falling under gravitational pull. In this case, when we turn this round, okay, we can leave our SUVAT there because we're going to use the same variables to describe the event. And so in this case, we've simply got a tall building. Here's our student on the top. He's got a long arm and he's going to drop an object from there. It's going to fall from there down to the ground here. Okay. Once again, we can only describe it if it's got constant acceleration. So S here is going to be the distance that it falls. U here is going to be the initial velocity. V at the bottom here is going to be the final velocity. A is going to be the acceleration going down here. In this case, it's going to be G. It's going to be the gravitational pull, isn't it? Okay, which is acting on the mass there. G, pulling it down. And there's A, okay. And then T equals the time to fall over that journey. Okay. So although we've turned it into a vertical problem, a mass falling, because we've got gravity, because we've got a constant acceleration, we can use exactly the same process to describe it. We are, of course, ignoring air friction or the air resistance here because we need to just consider a constant velocity, a constant acceleration. So, let's put some values into this problem. I'll do it in red here. We don't know what the distance is. We know because we're releasing it here at 0, U, the initial velocity is going to be 0. We don't know what the final velocity is. In fact, that's the one we're going to try and find. We know that A is going to be gravitational acceleration, which is 9.81 meters per second squared. You should know that one. And in this case, for this particular event, we're just going to simply say that the time taken is going to be 2 seconds. Okay? Initial velocity here, 0, T, 5, final velocity, we don't know, and G here, the acceleration, 9.81. Okay? So we've taken a real life event here, we've measured it, we've taken variables from it, and now we're going to turn it into a mathematical equation. And the equation I'm going to use to describe this particular event here and calculate the final velocity here is V equals U plus AT. There it is. Once again, it's the final velocity we're trying to find, which is this term here, this variable here, V. We don't need to change the equation around because V is the subject of the equation. Therefore, we get V equals 0 plus A, which is 9.81, times T, which is 2 seconds. 2 seconds there. Okay, so what we've got here is simply V equals 0 plus, multiply these two out there, so I'm going to end up with 19 plus 6, 2. So the velocity equals 19.62 meters per second. Okay, which in this case, if we turn that into miles per hour, is about 42, 43 miles an hour. So we've got an event, we drop a mass, doesn't matter what the size of the mass is, it falls, it takes 2 seconds to fall under gravity, and by the time it reaches the bottom, it's going to be travelling at 19.62 meters per second.